Master cylinder, types of master cylinder, working principle of master cylinder, parts of master cylinder. The master cylinder in a car's stopping mechanism is a water-powered device in which chambers and some cylinders are organized in such a way that the mechanical power applied to the brake pedal in the car. An ACE chamber is a device in a hydraulic braking system that duplicates mechanical force applied by the driver via the brake pedal or brake lever. The master cylinder, like the brake disc/rotor, is an essential component of a disc brake assembly. Types of master cylinder. 1. Open system. A bladder inside the reservoir tanks makes up an open system master cylinder assembly. These bladders assist in adjusting the braking fluid level in the master cylinders. 2. Closed system. The master cylinder in a closed system does not have a bladder in the reservoir tank. 3. Single cylinder engine. The most basic master cylinder is a single cylinder, which is fundamentally identical to a plastic medical syringe. The plunger pistons inside the cylinders are pushed by the brake pedal lever, which causes fluid to flow through the lines and into the slave cylinder. Negative pressure draws the braking fluid from the lines and the reservoir into the cylinder. 4. Master cylinder with no port. Portless master cylinders, first seen on the Toyota Mr. 2, enable a speedier brake release than traditional systems that employ a compensating port. 5. Tandem cylinder with ports. A tandem cylinder has two pistons in one cylinder. When the brake pedals are depressed, the piston pushes against a spring linked to the secondary piston's back. The spring pressure pulls the piston back when the brake pedals are released, and a tiny compensating port from the brake fluid reservoir introduces extra fluid into the chamber. Parts of master cylinder. 1. Pedal or lever. This is the section of the master cylinder assembly where you provide the master cylinder instructions. 2. The return of spring. This has been observed in drum and disc brake systems. When the brake lever or pedal is withdrawn, the piston returns to its original position. 3. Pushrod. A lever and a piston are connected to the pushrod. 4. The piston. A pushrod and a return spring link a piston or MC pistons. 5. Piston assembly. A piston assembly is made up of a piston, a succession of O-rings, gaskets called cup, O-rings, circle P, primary cup, and secondary cup, as well as a return spring. 6. Bore. Caliper assemblies and master cylinder assemblies have a bore under which the piston glides. 7. Brake fluid. 8. Bladder. It's comprised of thin-walled rubber that can expand and shrink, allowing it to distort. 9. Reservoir. It features a glass through which you can see the oil level and color. 10. O-ring, gasket series. When the brake lever or pedal is squeezed, brake fluid from the reservoir flows over and into the brake hose pipe. 11. Hose pipes. The braking fluid is transferred from the master cylinder assembly to the caliper assembly through a tube-type conduit. 12. Use a clamp. When the brake lever or pedals are engaged, the piston is pushed by the pushrod connecting to the lever or pedal on the pistons. Master cylinder principle of operation. Master cylinder with a single circuit. When the brake pedal is not pressed, the cylinder stays in its unique position, sealing the bay valve of the repository and preventing contact with the brake. The pressure chamber is located in the center of the shop. The cylinder is connected to the brake pedal through the interface pole when the brake pedal is squeezed, allowing the brake fluid to flow from the storage to the pressure chamber. Because the cylinder inside the barrel is growing like a medicinal syringe, the brake liquid inside the pressure chamber is packed. The outlet valve opens once the brake fluid has been pressurized to a particular load, and this highly pressured brake fluid is transferred to the brake lines for extra brake activation. The working of the double ACE barrel is 70% the same as that of the single circuit MC, but in this Type 2, autonomous braking circuits are employed. Let's examine how it works. When the brake pedals are not depressed, the cylinder remains in its unique position, closing the delta valves of both pressure chambers and interrupting the braking fluid flow. The relevant cylinder moves first when the brake pedal is pressed, opening the needed bay valve. Developing the necessary cylinder causes the braking fluid pressures inside the required chamber to rise. When appropriate chamber pressure is reached, required outlet valve opens, the packed brake fluid is supplied through the brake lines to the brake calipers, and the required circuit brake is activated. The auxiliary outlet is opened once the brake liquid has been packed. This thoroughly compressed liquid is supplied through the brake lines to the brake calipers, and the alternating circuit brake is activated. Thanks for watching.